Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids. Math, science, history, unraveling the mystery that all started with a Big Bang.
Balancing chemical equations is an essential topic for succeeding in chemistry. So today we're going to show you how to balance chemical equations while also showing you the basics of the law of conservation of mass and explaining to you the 5 types of chemical reactions. I'm going to begin with the law of conservation of mass. All the law says is that mass is neither created nor destroyed, it's only transformed. In relation to the equations, this means that the mass of the reactants must equal the mass of the products. You can see that in this example. If you add up the mass of the hydrogen and oxide on the left, it will equal the mass of the water on the right. Now that we've refreshed your memory on the law of conservation of mass, we're going to move on to balancing chemical equations and the types of chemical equations. How this is going to work is we're going to give you an example of each type of chemical equation and how to properly balance that equation. Look for the importance of the law of conservation of mass in each example.
Synthesis occurs when 2 reactants form one product. This is the equation for water. The reactants both have subscripts of 2 because they're diatomic. So there are 2 hydrogens and 2 oxygens on one side and 2 hydrogens and 1 oxygen on the other. To get 2 oxygens, put a big 2 right here. Now there are 4 hydrogens and 2 oxygens. Now this is not equal, so we need to put a big 2 right here, making this 4, and the equation is done and balanced. This is a synthesis problem because there's 2 reactants and 1 product.
In a decomposition reaction, reactants are broken down to form simpler products. There is always only 1 compound as a reactant. So this is a decomposition reaction, and you can tell because there's 1 reactant and 2 products. And so we have the equation H2O yields H2 plus O2, and we can tell that it's not balanced because there's only 1 oxygen on that side, but there's 2 on that side. And so in order to balance it, we have to put a 2 right here, which gives that 4 hydrogens and 2 oxygens. But you can see that we're still not balanced because there's 4 hydrogens here and there's only 2 here. So we have to put a 2 in front of that hydrogen. So now we have 4 hydrogens on both sides and 2 oxygens on both sides.
A single replacement equation occurs when one element trades places with another element in a compound. Alright, this is a single replacement equation, and the way you're going to recognize this one is there's going to be 1 compound and 1 lone element on each side of the equation. So down here in our example we have zinc and hydrogen chloride, and what's going to happen is the zinc is going to trade places with the hydrogen, and it's going to bond with chlorine. So, but before you do that, you have to refer to the activity series, which will be explained in a different video, so I'm not going to explain it. But before we finish, you need to balance it with the 2 in front of the hydrogen chloride.
Double replacement is when 2 elements trade places with another 2 elements in a compound.
Okay, so this is a double replacement equation, and you can tell because there's 2 different compounds that are reacting to form 2 other different compounds, and the way you can see this is red changes. So as you can see, they crisscross, and this is an example of a balanced one, and I just want you to notice that chlorine in here only has 1 molecule while it has 2 over here. That's because for each compound you create, you have to redo the amount of molecules with what it's bonded with.
In a combustion reaction, a hydrocarbon and oxygen react to form CO2 plus H2O.
So this is a combustion equation, and combustion equations involve a hydrocarbon plus oxygen yielding carbon dioxide plus water, as you can see. And to balance it, you need to have equal molecules on each end. So you're going to go ahead and put a 4 on the oxygen, just because you're going to need 8 molecules, and then you're going to put a 3 in front of CO2 to match the 3 on carbon, and you're going to go ahead and put a 2 in front of H2O to match hydrogen. So you have 4 molecules of hydrogen on both ends, 3 of carbon on both ends, and 8 of oxygen on both ends.
Here are a few practice problems to help you review the topics that we covered today.